A diatomic molecule has a dipole moment of 1.2 d. If its bond distance is 1 angstrom, what fraction of an electronic charge E exists on each atom? Each atom they are asking the distribution of this charge. Now you know the dipole moment is nothing but the charge into distance. This is the charge present on the atoms. So dipole moment they have given 1.2. So right here 1.2. So d. So 1d is 10 per minus 18. You can say ESU. So already we know that. So 1d is equal to this much value, and they are asking charge. So charge is q, and the distance is given 1 angstrom. So 1 angstrom is 10 per minus 8 centimeter. If you solve this one, so you will get here. So charge will be equal to, so it will be 1.2 into 10 per minus 10 ESU. Now this is the charge on the atoms. Now they are asking fraction of charge. Means fraction of charge means the charge of in ESU is total charge is actually 4.1 into 10 per 4.8 into 10 per minus 10. So for fraction of charge, so fraction of charge means you have to divide with the actual charge of the this one on the atoms. So it is 1.2 is the 10 per minus 10 on the atoms, and total charge is 4.8 into 10 4.8 multiplied by 10 per minus 10, and this is the ESU per electron. This is the ESU, and you multiplied by 100. So you will get answer 25%. So if you see carefully, this answer is correct. A particular 100 octane aviation gasoline used 1 ml of tetraethyl lead is of density 1.6 gram per cubic centimeter per liter of product. The compound is here is formed like this one. This is a reaction. Ethyl chloride is reacting with the sodium lead. You will get this product. Now question is, how many grams of ethyl chloride this is needed to make enough tetraethyl lead for 1 liter of gasoline? So for 1 liter gasoline, how much moles of this is required? We have to find first how much moles of tetraethyl lead is taken from here. Then we can decide from this one, because 1 mole is giving 4 mole. So how many moles we require, that much ethyl lead is required. So already density of ethyl lead is given, and volume is given. So we can say mass of TEL, that is tetraethyl, will be 1 into 1.66. So it will be equal to 1.66 gram. Now moles. So moles of TEL will be how much? So it will definitely 1.66, and if you calculate the molar mass of tetraethyl lead, so this will come about 323. So this is the molar mass of the tetraethyl lead, and if you solve, you will get answer 0.00514. So this is the value, and this is your mole. Now we know that for 1 mole we require 4 moles of ethyl chloride. So for 1 mole we require how much? 4 moles of C2H5Cl. Now for this much mole means 0.00, we can say 514. So it is 4 into 0.00514. So this means the 0.0206 moles is required. Now if you multiply this whole into molar mass of tetraethyl lead, the molar mass of tetraethyl lead will be 64.51. This is the molar mass, and if you solve it, so you will get 1.33 gram. So this is the answer. So answer A is correct. 1 mole of benzene, 1 mole of nitric acid, and 0.05 mole of H2SO4 are mixed, and you are adding water. After adding water, what is the pH of the solutions if the final volume is 1 liter? You know, acid plus HNO3, it will react each other. So when a nitric acid reacting with the H2SO4, it will give you NO plus. This acid base reaction. So nitrosonium ion is produced, and with nitrosonium ions, HSO4 is negative plus water is there. Now this will react with the benzene C6H5. So what will happen? And so reaction, this is, and in presence of HSO4, both will react. So this will form nitrobenzene, this will form nitrobenzene, and hydrogen from the benzene will given out. So it will again H2SO4 is regenerated. This molecule again regenerated. So previously one hydrogen was lost and then again regenerated. So this amount of 0.05 moles is there. So this is 0.055 moles. Okay, and again one more hydrogen generated, so we can say 0.005 into 2, so there will be how many moles of hydrogen? So it will be 0.001 moles of hydrogen is there. So concentration of H plus ion will be this much mole. So what is the pH value? So pH will be equal to minus log of whole concentration, that is 10 power minus 2. So if we solve it, it becomes 2. So answer will be 2. Arsenic sulfide is oxidized by the concentrated nitric acid into As5 plus and SO4. What is the equivalent mass of As2S3? So we can solve here. So As2S3, so it in presence of nitric acid, that is concentrated nitric acid, so you will get compound As5 plus and sulfate, this is your sulfate is 2 minus. So if you see the arsenic here, charge is plus 3 and for sulfide charge is minus 2. So first we have to find the what is the total N factor, then we can decide the equivalent weight of this is. So total N factor for arsenic, so if you see plus 3 to plus 5, so 5 minus 3 for arsenic, so 5 minus 3 multiplied by 2, so it will be total 22 4. N factor for arsenic is 4. Again minus 2 to this is your plus 6, so total is 8. 6 minus 2 8. So we can take for sulfur, so this is 3 sulfur, so we can buy 3 into sulfur is 6 minus again minus 2, so this is 8 into 3 24. So total N factor will be 28. Now for sulfide, so equivalent mass will be molar mass of As2S3 and divided by 28. So this answer is correct.